this video is on drawing Lewis structures, and we'll be using this kind of guided note paper. Okay, so before we start, and there is not a tab on, or a bullet point on your paper for this, okay? So you're on the right paper, yes, if you have this. There's no place for this, so I would just recommend that you squeeze this little definition up in this upper right-hand corner. So, we're going to do a brief discussion of something called electronegativity. And electronegativity is a fancy word for how much an atom wants an electron when it's in a bond, okay? When it's in a covalent bond. So, for example, we might have the compound HF, okay? And the question here is, well, who wants the electron more when those two atoms are connected together? Hydrogen or fluorine? And so the way we determine this, it's pretty easy. It's just a trend. And a trend is a pattern, okay? And so electronegativity increases as you move up a group in the table, and it increases over to the right, with fluorine being your most electronegative element. We exclude the noble gases because the noble gases have no desire for an electron. Remember, they already have 8. They already have their octet. And so fluorine is your most electronegative element on the table, and making francium, who's in the bottom left corner, your least electronegative. Okay, so in the discussion between who wants the electron more with hydrogen and fluorine, it's a pretty easy answer. The fluorine is more electronegative. Okay, and that's going to come into play just a little bit in drawing Lewis structures, so I wanted to introduce that topic so that wasn't a unknown. Okay, so now to our real notes. So we're going to start off with talking about what is a Lewis structure. Okay, and a Lewis structure is a picture, okay? It's a two-dimensional picture that shows bonded and non-bonded electrons in a covalent molecule. Okay, a two-dimensional picture that shows bonded and non-bonded electrons in a covalent molecule. Remember, covalent, two nonmetals, and electrons are shared. So this Lewis structure is really going to give us a picture, so to speak, of how the electrons are being shared in a molecule. Okay, so now that we know what a Lewis structure is, we're going to learn how we draw one. So the next heading says rules for drawing Lewis structures. And so what we're going to do is kind of list the rules down the side of your note paper, okay, under this heading. And then kind of over to the right-hand side, we're going to draw our first Lewis structure together, okay? So what might happen is you might encounter a problem that says something like, draw the Lewis structure for the molecule Cl2. Okay, so that would be the direction that you're given. Draw the Lewis structure for the molecule Cl2. So here are the rules that we're going to go through. And then, like I said, we're going to draw it together over on the right. So the first rule is going to be that we're going to count the total valence electrons. Okay? Count total valence electrons. And remember your pattern across the periodic table to count valence electrons, right? Group 1 is 1. You don't have to draw this because you're probably going to run out of room. But remember, it looks like this. 1, 2, we skip 3, 4, 5, 6, 7, and the magic number of 8. Okay, so if you want to write that down, you can. But that is how we count valence electrons. And so in my molecule Cl2, I have 2 chlorines. And each chlorine has 7 valence electrons. So essentially I have 2 times 7, right? Which is 14 valence electrons that I'm going to work with. 2 because I have 2 chlorines, and 7 because each chlorine brings me 7. So, or 7 plus 7, right? Same idea. All right, so that's my first rule for for drawing Lewis structures is to count the total valence electrons. My second rule is to arrange my atoms. Now this one has some some sub rules, so to speak. Okay, so we'll do little bullet points. If there's only 2 atoms, we place them side by side. Okay? And that is the case with this, right? There's only 2 chlorines. So when I go to arrange my atoms, there's really no other way for me to arrange them other than putting a chlorine kind of next to another chlorine, okay? But there's some other possibilities that we need to discuss. The second one is if there's a carbon. And so the second sub-rule of this is that if there's a carbon in your Lewis structure, your carbon will go in the center and everything will connect to your carbon. And we'll see that here shortly. But this is not the case this time because I don't have a carbon. I only have 2 chlorines. And then I have a third rule, which basically says that if none of the, if neither of the first 2 apply, okay, then you'll place, and here comes why we just learned electronegativity, you'll place the least electronegative atom in the center. Okay, and that is only if there is no carbon and if you have more than 2 atoms. Okay, and we will see that shortly. And I'll give you an example, and I will refer back to that. Okay, so for now we've arranged my 2 atoms. This was the first bullet point. I only have 2, so they go side by side. So onward we go. So rule 3. We're going to add the valence electrons to each atom. And we're going to do that by putting in the electrons as dots, kind of like we did when we first learned about covalent bonding, and even ionic bonding, okay, when we learned about transferring electrons. And these were those things that were called Lewis dot structures. So we go back and we say each chlorine has 7. So I'm going to give each chlorine 7 dots. Right, to represent the 7 valence electrons. And I'm getting smart about my electron placement, and you're going to catch on very quickly as to why. And it doesn't really matter where the electrons go. It is normally done with the fact that they're kind of in pairs. You see how I have 2 and 2 and 2. Okay, it just makes counting later easier. But okay, so I've done that. I've added my valence electrons to each atom. My 4th rule is that I'm going to bond them together. And bonding them together, it takes 2 electrons to make a bond. Okay, 2 electrons make a bond. So this is why I've placed the electrons the way I have, because I have this 1 electron and this 1 electron that are kind of screaming to be connected. So I'm going to connect them together. And I have just bonded my 2 atoms together and formed a covalent bond. And in that bond, there are 2 electrons. And then my 5th rule is just to count and check. And I'm counting and checking 2 things. 1, my total valence. And 2, does everybody have an octet? And this is how you can answer if your Lewis structure is correct. Okay? So you can't forget this step. It's so important. We have to count and check 2 things. In this case, are there 14 total electrons in my picture? And that's this first one. And then, does every atom have an octet? Okay, so we'll do the 14 rule first. I have to have 14 electrons. So 2, 4, 6, 8, 10, 12. And remember, this bond is made of 2 electrons. So yes, it does have 14 electrons. So I'm good for that. And my second one is, does every atom have an octet? So if I look at this chlorine has 1, 2, 3, 4, 5, 6 electrons all to himself, but he has access to these 2 electrons in the bond because they're shared, which gives it 8. The right side chlorine has 1, 2, 3, 4, 5, 6 to himself, plus access to these 2 electrons in the bond, gives it 8. Everybody has an octet, and this is the Lewis structure for Cl2. This is called not only a covalent bond, but it's called a single bond, which might hint that later there is something other than a single bond. Okay, so that's your quick overview of how to draw a Lewis structure. We start with counting valence electrons. We arrange them in the correct arrangement. We add the valence electrons to each atom, bond them together, and then we count and check, moving electrons around if needed, which we'll see later, for total valence and for does everybody have an octet. Okay, so now if you notice on your paper, there's 4 practice Lewis structures. It says draw the Lewis structure for H2O, HF, CH4, and NH4 plus 1. If you would like to try those on your own, you can pause this video. Or if you would rather see me do some more examples, you can just keep watching. But I'm going to go straight into that and do those 4 Lewis structures. Okay, so we'll do kind of 2 at a time. So H2O and then HF. Okay, so count valence electrons first. So each hydrogen brings me 1 valence electron. So that's 2 hydrogens with 1 electron. So 2 times 1. Added to that, the fact that oxygen brings me 6. So in this picture, I should have 8 valence electrons. Okay, so I need to think about how I'm going to arrange these atoms. Now in this case, I have more than 2, so they won't go side by side. I don't have a carbon, so this is the case where I will have to decide on my ordering of the atoms. So my rule was you place the least electronegative in the middle, which is actually hydrogen, but hydrogen's an oddball because hydrogen, if you think about your periodic table, hydrogen wants to act like helium, who has 2 electrons, and that's a exception to the octet rule. Okay, so hydrogen will never be in the middle. You might want to write that down. Hydrogen will never be in the middle of a Lewis structure. So in this case, my oxygen has to go in the center. Oop, that was a pretty bad O. And my hydrogens are just going to go around it. Okay, so I just put them on either side. So my next rule was I forgot my next rule. I add my valence electrons. That's what it was. So oxygen has 6. So 1, 2, 3, 4, 5, 6. And each hydrogen has 1. 1 and 1. I'm being kind of smart about my electron placement because I know next I'm going to connect those electrons to form bonds. So I'm going to connect this one and this one, and this one and this one. Okay, and so I have a structure, and now I'm going to think about, is this correct or not? So first, do I have 8 electrons in my picture? Well, I have 1, 2, 3, 4. Remember, 2 here, 5, 6, and 2 here, 7, 8. So yes, I do. So that's a check. And then, does every atom have an octet? Well, oxygen definitely has an octet. 1, 2, 3, 4, 2 in the bond, 5, 6, and 2 in this bond, 7, 8. Oxygen's good. And in this case, you might think hydrogen's not, but hydrogen only wants 2 electrons. And so this hydrogen has 1 and 2, and this hydrogen has access to 1 and 2. So everybody is good here. That's another thing you might want to write down. Hydrogen can never be in the middle, and hydrogen only ever wants 2 electrons. Why 2? To act like helium, to fill that first energy level. All right, so that's H2O's Lewis structure. And then let's do HF. So same process, valence electron, 1 for hydrogen, 7 for fluorine, total of 8. In this case, I only have 2 atoms, so they're going to go side by side. Put my valence on, 1, 2, 3, 4, 5, 6, 7 for fluorine, 1 for hydrogen, connect to form that bond. Count. 1, 2, 3, 4, 5, 6, 2 in the bond, 7, 8. Yep, I have 8 in my picture, good to go. And does everybody have an octet? Well, fluorine does. 1, 2, 3, 4, 5, 6, to himself, sharing 2 in the bond, that's 8. And hydrogen doesn't want an octet, only wants 2. In fact, does have 2. So that's my correct Lewis structure. CH4 and NH4 plus 1. All right, so CH4, count valence, 4 for carbon. Each hydrogen brings me 1, so that's 1 times 4, total of 8. It seems to be a very common number on these practice ones. More than 2 atoms, but I have a carbon for the first time. So carbon will go in the middle, and the 4 hydrogens will connect to the carbon. So I'm just going to surround the carbon with the 4 hydrogens, okay? Put in my valence, hydrogen gets 4. Carbon gets 4. And see, again, you're getting smart about your electron placement. Knowing you're going to connect these dots, and each hydrogen has 1. So I connect, 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 Okay. Check for total valence. Yes, I have 8 total valence, 2, 4, 6, 8. And does everybody have an octet? Carbon definitely does, has 2, 4, 6, 8 in the bonds, and all my hydrogens have 2. All right, my final practice one was NH4 plus 1. Now this one's different. Okay, if you notice, it has a charge. I have to take that into account. So here's my total electron count. Nitrogen brings me 5. Each hydrogen brings me 1. So that's 4. Gives me a total of 9. That might not sit well with you because it's an odd number. But this charge means that it's a cation. And it got a +1 charge by losing an electron. So this thing doesn't have 9 electrons. It has 8 electrons. Okay. So, again, my hydrogen cannot be in the middle, which means nitrogen's going to be in the middle. And my 4 hydrogens will surround it. Okay. And I put in my electrons. So each hydrogen gets 1. Nitrogen gets 5. And I form bonds. Okay. Sorry. And I have a discussion about total electrons. But all of a sudden, I have 2, 4, 6, 8, 9. And while that was my initial number, right, I need to subtract an electron. And so I have not done that. So I physically will remove an electron so that I have 8. So now I have 8. I check for the octet. Oh, hydrogens have 2. Nitrogen has 8. 4 bonds, right? 2, 4, 6, 8. Everybody's good. 8 total electrons. Everybody with an octet. We're good to go. However, there's one additional step you must do. It's very simple. To show that this is an ion, you put the whole thing in brackets and you put out to the side that it has a +1 charge, which tells the reader of your Lewis structure that you removed an electron. Okay. So, one more topic, which is the topic at the bottom that says double and triple bonds. And the bullet point says sometimes atoms bond by sharing more than one pair of electrons. So, what would that look like? Well, attempt, and for just a minute, to draw the Lewis structure for O2. Okay, so you can, if you want to do that for a minute, pause this video and attempt to draw the Lewis structure for O2. And actually, for that matter, attempt to draw the Lewis structure for N2. Okay, so pause this video for a minute, try to draw those, and then I will just go right into the explanation. So if you go to do a Lewis structure for these, O2 is 2 oxygens, each with 6 electrons, brings me to 12. And nitrogen, 2 nitrogens, each with 5, gives me a total of 10 electrons. Okay, so with O2, of course, they go side by side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I know I have to connect my dots, so to form a bond, here it is. And now I go and I check, does my picture have 12 electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, it does. But do all my atoms have an octet? 1, 2, 3, 4, 5, 6, and 7 in the bond. And the answer is no. Now, what some students like to do is they try to fix that by doing this. Ta-da, I fixed it. And now while they all do have an octet, I no longer have 12 electrons. And so I am not allowed to do that. Okay, I cannot add any more electrons in because I'm already at my max of 12. So in this case, I have to take these oxygens and make them share more than 2 electrons. So I'm going to make them share this electron and turn it into another bond, okay, which you might guess is called a double bond. It's made of 4 electrons. So check this out. Do I still have 12 electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I do. And do all my oxygens have an octet? They do. 1, 2, 3, 4, 5, 6, 7, 8. Same for this one. So in this case, you cannot draw a Lewis structure for O2 unless it's with a double bond. For N2, it's very similar. I put my nitrogen side by side, give each one 5 electrons. Okay. And I connect my dots. Okay, so I have a structure. I have 10 electrons, but they definitely don't have an octet. Look at nitrogen. 1, 2, 3, 4, 5, and 6. Not good. So you might be inclined to say, well, I need a double bond. So I'm going to take this electron and I'm just going to move them. Okay, and you can totally do that. That's valid. I can move electrons anywhere I want. And so there you go. I now have a double bond, but if you look closely, neither nitrogen has an octet. 1, 2, 3, 4, 5, 6, 7. I'm so close, but even a double bond won't satisfy this. And so I need to form a triple. So I'm going to pick these electrons up, move them right here, share them. And now look, I have 2, 4, 6, 8, 10 electrons in my picture. And each nitrogen has 1, 2, and they are sharing a total of 6. So they have an octet. This is called a triple bond. And it is the sharing of 6 electrons. So that's a basic, fairly quick overview of how to draw a Lewis structure. On the back of your paper is several practice problems for drawing Lewis structures. Some are easier than others. So I would like for you to attempt to solve these. And then I will post a second video that has the answers. Or that has an explanation, I guess. Has an explanation of how to do those practice Lewis structures.